All right, so we're moving on to page 4. So the first question here is determining the area and perimeter modeled by these inequalities. So first step is going to be to identify how to graph the inequalities. We need to get y on the left side, so like y equals mx plus b form, and then identify the slope and y-intercept so we can graph the line. You can also use your calculator for this, so that's an option for you guys. And then I can post a video on that as well a little bit later. So here we go. Starting off with the first one. Okay, we're going to add x to both sides to start with. So we'll get y is less than or equal to x plus 5. So I always write the x in front because it's mx plus b form. It's easy to identify the slope. It's just the number in front. Here it's a 1 because there's nothing there. So 1 over 1 or just 1. And then b is 5. This less than or equal to is going to help us with our shading. So we want to shade the y values that are less than or equal to that line. We're going to start by plotting 5 on the y-axis. Oh, remember what we did in class? Totally forgot. We changed this to a plus sign and this to a plus sign. So really we want to subtract this. So it's going to be negative x plus 5. So it's still 5, but now our slope is negative 1. So we're running back this way. So we plotted down 1, right 1, or up 1, left 1. I'm going to take our awesome ruler. All right. So this is a solid line because it's an equal to graph. And we have y less than or equal to negative x plus 5. And we are essentially shading down from here. So we're shading all the ones that are less than or equal to this. All right. Second equation is y is equal to 3 plus x. We can also rewrite this less than or equal to and put the x first, so it's just x plus 3. So our slope is 1. Our y-intercept is going to be 3. Remember, we can also write this as 1 over 1 here, right? Just for our slope. We're going to go 3. We're going to go up 1 and over 1, or down 1 to the right, or up 1, down 1, and over 1 to the left here. So we're doing 2 negatives or 2 positives. Just trying to get this situated. And if you haven't heard, the bills have traded to Cordy Glen apparently. So get some more assets here. I have no idea what they traded for, but we'll find out later. And then this, once again, label your equations, is y is less than or equal to x plus 3. So it's less than again, so we're shading down. Okay. And then the last graph here is this 8y, and here we're just going to divide by 8, and we're going to get y is greater than or equal to 1/4 x. Really, it is plus 0, because we can add a 0 on without a y-intercept here. So our slope is just 1/4. Our y-intercept of b is 0. We're graphing right at the origin, going up 1 and over 4. We're going down 1 and left 4. In first period, we didn't switch these around, and we ended up with a different triangle. So your region may be a little bit different. I have posted a blank worksheet for you guys, so you can go through and kind of do that one on your own. All right. So we're going to get that line right here. Once again, that's y greater than or equal to 1/4 x here. So we're shading up from this. Okay. So you can see we're ending up with this triangle right here. All right, that's our triangle. And so what we want to do is do the perimeter in the area. And we want to essentially just encase this in a box. Now my box, notice I'm basically drawing a right triangle connecting each of these points together, each of the vertices here. So All right. And then we're just going to count now, right? So we want to figure out the area of that triangle. We'll call 1, 2, and 3. And we can count. This is 1, 2, 3, 4. This has a length of 5. This is a length of 3. This is 3. That's 2. This is 8. And this is 5. Okay? So when we do our triangles, the area part of this, okay, we want to do the area of our rectangle, which is just base times height. So the area of the rectangle is 5 and 8, the base and the height. So it's just 8 times 5, which is 40 units squared. And then we want to do triangle. So triangle 1, this is 5 and 5, so it's 1/2 base times height. That's 1/2 5 times 5, which is 12.5. We do triangle 2. That's 1/2, same thing, base times height. Here the side legs are 3 and 3, and so this works out to 4.5. And then the area of triangle 3, which is 8 and 2, so it's 1/2 2, which just gives us 1 times 8 is 8. So these three triangles all add up to 25 units squared, right? Units squared. So the total area is just 40 minus 25, which is 15 units, right? Squared, u squared. And that's it. That's our area. Okay, the perimeter is a little bit more difficult. So it's, I don't say difficult, but essentially what we want to do is figure out the length of each of these vertices created by these inequalities here. So the first one we have is this one right here, and so we have these 2 points. So if you want to bust out the distance formula, you just can identify that this point is the point -4, -1. This is the point 4, 1, and then you're going to go do your distance formula. Okay, we'll do the distance formula once. We'll look at the Pythagorean Theorem as well. It doesn't really matter. What I like to do is identify, though, for A, B, C. So we'll just call this A, right? B and C. And it should be a little bit better labeled, but that's all right. Okay? Okay, I'm doing a video. You got to hold on, honey. So D equals square root. And this is for A, B. Okay, I'll fix it in a little bit. So we got A, which is -4, -1. So the x-axis is -4 squared plus 4 squared. Sorry, -4, right? -4 squared plus, and then we got from -1 to +1. So that's -1 minus 1 squared. And so when we do this, we're going to end up with this -8 squared plus -2 squared. And here we end up getting the square root of 68. And if we simplify this, this is essentially 2, 2, and 17. And this is 2 radical 17. So that's the distance of AB. That's the distance of this bottom line right here. Okay, so that's the distance formula. Remember, it's x2 minus x1 quantity squared plus y2 minus y1 squared quantity squared. The other option here is to use Pythagorean theorem. So if I'm counting on these guys right here, here's triangle 2, right? We're just going to use a 3 and 3. So it's a squared plus b squared equals c squared. It's 3 squared plus 3 squared equals c squared. This is 18. And then I bust out the square root. Now, when we simplify, this is 2 times 3 times 3. And this is just 3 radical 2. Okay? In a minute. Who is that?
Me.
That's you. All right. Here, say hi.
Hi.
Look up.
Hi.
Then you're on the screen now. Okay. They'll see you when they watch the video later. All right, then we do the next one. So a squared plus b squared equals c squared again. Here we already did this one. We're doing the 5 and the 5. So 5 squared plus 5 squared is equal to c squared. This ends up being 50. Take the square root. this becomes 2 5s, this is 25, and a 2, and so this is 5 radical 2. So when I add these together, we're allowed to add these two because they have the same radicancy number in the radical. And then all we do is treat it like an x. So it's like 3x plus 5x. Okay? And then we add that on. So the perimeter. Hold on, get out of here. I'm not done yet. Okay? You can say hi again in a second. 2 radical 17 plus 3 radical 2 plus 5 radical 2. We add the radical 2's together. We get 2 radical 17 plus 8 radical 2. All right. Perpendicular bisector. Come over here, hi again. Okay, that's it for now. Since I'm done, I'll help you out, okay? So perpendicular bisector. You think about it. I have a segment right here. I want to draw a line that's going to cross through the middle. So I need to know the midpoint. I need to know this slope. And my line is going to have the perpendicular slope. And then I can do the y-intercept and get it, okay? So first things first, let's do the midpoint. So the midpoint is going to equal the average of the x's. Don't touch that. So x2 plus x1 over 2, y2 plus y1 over 2, and then we're going to plug in. So this is 4 plus 6 over 2, which is 10 over 2 or 5, and negative 1 plus 3 over 2. So we said 10 over 2. That's 2 over 2. And here we end up with a midpoint of 5, 1. Don't forget your parentheses here. Okay? The next one we got after the midpoint is the slope. So the slope between the 2 points, once again, is y2 minus y1 over x2 minus x1. We're going to plug in, so y2, second y coordinate, is 3, minus the first y coordinate, which is negative 1. That becomes a plus positive. And then we have second x is 6, minus the first x, which is 4. So this becomes 4 over 2, which is 2. Remember, our perpendicular slope is the negative reciprocal of this. So it's the negative 1/2. We have our midpoint, which we're treating for x and y. We now have our negative 1/2 slope. And now I can go do the rest. So I take my y equals mx plus b. I plug the y coordinate, which is 1. I plug the x coordinate in here, which is, well, first the slope, negative 1/2, then 5, then plus b. So this is 1 equals, this is negative 2.5 or 5 over 2. I'm going to add 2.5 to both sides and end with 3.5. So there's my y-intercept, there's my slope, and now I can do the equation as y equals negative 1/2 x plus 3.5, which is also 7 over 2. So if you want to use that, you can. All right. And last but not least, the lines 3y minus x plus 12 or equals 12, and 6y minus or equals 2x minus 24. Are they parallel, perpendicular to the same line, or either? So first of all, what I want to do is find the slopes and y-intercepts. So for the first equation, we'll take the second one here. I can divide everything by 6, and I'll have y equals mx plus v form. And that's really the key. We want to go about getting this into y equals mx plus v form, both equations, and then comparing their slopes. And the second equation, or the first one here, right in front, we are going to take this, okay? We are going to get y equals again, so I'll move x to the other side. So 3y is equal to x, remember we put that in front, that's 12. We divide by 3, and then we can compare. So y is here is equal to 1/3 x plus 4, and we can see that the slopes here, that 1/3 we got earlier, and then over here, we also got a slope of 1/3, so we can tell that they're parallel. If we had to explain, we just say like, you know, when we get in y equals mx v form, the slopes are the same, therefore the lines are parallel, and we're good to go. All right, guys. I'll follow up a couple of videos just to help out on certain topics. So just pay attention to remind every once in a while tonight. Check it out, and we'll go from there. See ya.